Hi, welcome to Wise Guys. Electric, potential energy, and potential. This is practice question 3. This question is a positive charge of 0.3 microcoulomb. Small charge is moving from point A to point B. In a parallel plate with electric field strength is 100 volts per meter. So that means this one is E. So give us E equals 100 volts per meter. The small q equals positive 0.3 microcoulomb, which is 3 times 10 to the negative 7 coulomb. And the distance between point A and B is 12 centimeters, which is DAB equals 0.12 meters. We need to convert to SI unit. And it's the same as the distance between point BP and B and C, so the DBC also equals 0.12 meters. They ask for is the work done by electric field force or by an external force when we're moving from the small q from A to B or from B to C. Let's first say the positive small charge from A to B. So, okay, this one is A, here is B, positive charge, because the field line is this way. That means this is positive charge plate. This one is negative charge plate. And so the force is electric field force going this way, because positive charge is exerted by electric field force as same as the field line. Also, you can see this positive charge and the positive plate, they repel. Or positive charge, negative charge, the attraction. That's a force, and with the moving direction, and the force have same direction. That's why this is the work done by electric force. The electric field force doing work. So electric force, this is does work, okay? And how much? So let's use formula. The work from A to B, in this case, because this is a parallel plate, is uniform electric field. That means any place at any point, the electric field strength is 100 volts per meter. And also we can, even we don't have this plate, if we given the field line is parallel and the equal distance, then we know that is uniform electric field. So the charge in uniform electric field, the force also is a constant. When the force is constant, we can use W equals F times D. F times D with DAB. Looking for the work from A to B, you call the force, which has to be constant, multiply the distance between A and B. So how to find the force? Force equals field strength times Q. This is the definition. So we go to the next page. We have F. We first find F equals E times Q which equals 100 volts per meter, multiply Q, which is 3 times 10 to the negative 6, negative 7 coulomb, because 0.3 microcoulomb convert to coulomb, right, is 3 times 10 to the negative 7 coulomb, which give us, this one is 3 times 10 to the negative 5 Newton. And we can calculate the WAB equals force times distance AB, which equals 3 times 10 to the negative 5 Newton, multiply the DAB is 0.12 meters, which give us, this one is 0.36, which is 3.6 times 10 to the negative 6 Newton meter. Now is joules because work. This is find the work moving charge, positive charge from A to B. And also we can find what the potential difference between point A and B. The potential difference between A and B, we use formula. There are two formulas we can use. One is follow the definition. Definition is VAB equals WAB divided by Q. The other formula is special for using in uniform electric field, which is this one, which is VAB equals is both same. We can use both. One is VAB equal definition WAB. The other is in this situation is E times D, not divided, E times DAB, E times DAB. So both okay. So let's use the definition equals to WAB is 3.6 times 10 to the negative 6 joules. Divided the small q is 3 times 10 to the negative 7 coulomb. So give us answer is 3.6 divided 3 is 1.2. This negative 7 becomes 12 volt. And this is talking about AB. Then we talking about the moving charge from BC, from B to C. B to C, in this picture you can see B, C, this line, dot line is perpendicular. This is perpendicular to the field line. So field line is this way, and the BC is this one. This is B, this is C, parallel, perpendicular. That's why we can see the work, the force is still same direction. The positive Q put here, the force is this way, and the moving direction is this way, which is perpendicular. So that situation, this angle is 90 degrees. As we know, WBC equals F times DBC times cosine theta, which is 90 degrees. Because cosine 90 equals 0. That's why the work done in this situation, moving charge from B to C is 0. No work needed. After that, then we can find the VBC, because VBC equals WBC divided Q, because the work done is 0. That's why even the Q is not 0, because 0. That's what means VB equal VC. So that's why VC, at this point, the potential difference between B and the C equals 0. So this is presented by wise guys. Thank you.